to that homework. What? We're gonna add to that homework. Okay, homework for tomorrow, and I will be checking this one. So homework for 9.1, page 394 still. Do 18 to 24. We were just adding to yesterday's homework. Yep. 18 to 24, yep. And you should have already done 18 to 20. Hopefully. Mm-hmm. What? That's it. That's it for homework. Oh, no.
Oh,
Because this is the end of the unit, because we're going to the next lesson, technically. Okay. Go up, and we are doing a new one. Moving to 9.2. Okay, this whole entire chapter is a little choppy. Okay? We're learning something new pretty much every single time. So this is proof. Using the coordinate plane. Okay, we're gonna pause this for a second. We're gonna keep going. So we're proving using coordinate plane. Can anyone remember the trapezoid mid-segment theorem? Okay, do we all know what a trapezoid looks like? Yes? Okay. Is this a trapezoid? If I said this, is this a trapezoid? Very true, Elijah. That is very true. But if we were using Alaska definition, would this be a trapezoid? No. What do I have to change about it? Sort of intersect, yeah. I have to change this side to this side. Yep. So that this side is parallel to this side. And I'm going to erase this. This is my trapezoid right now. Now, who remembers the midpoint theorem? I'm going to draw my little midpoints here. This is the midpoint of this line. You guys look back. This is the midpoint of this problem, this side. This is the midpoint of this side. If I drew a line right here, what can you tell me about this line? Say it, Sonny, you got it.
no.
2/3? 2/3 of the longer base? It's 1/2 the sum of the top and the bottom. So it's the average length. It's the midpoint, mid-distance between these two lines. And it's also what? Parallel. Yep, it's also parallel. So we're going to write that down because I think we have forgotten it. Trapezoid. Mid. No, it's not mid. Mig segment theorem. So we're working on how do I prove this information if I put it on a coordinate plane. So the mid segment of a trapezoid is parallel to each base. And its length is 1/2 the sum of the lengths of the bases. So I'm going to put it on the coordinate plane a very particular way, and I'll show you that after you guys write this down. I'm going to pause. Who can remind me what the coordinate plane is? Yep, a graph using like a scale. I have a coordinate plane. I'm gonna draw that right here. And I'm gonna make sure that this point right here is right at the origin. I really want that right at the origin because it's gonna make this so much easier. So Tristan, if that's the origin, and this is my y-axis, this is my x-axis, how would you write this coordinate pair? 0, 0, yeah. With a 0, 0. And I'm also going to label this A. This is A. If I had B over here, what would you want to label B? Would it be its coordinate pair? Anyone? 7, 0? Okay, we don't know it's 7, right? So we're just going to call it... Let's call it B, because we're at B. B, 0. Okay? Now, if I have this point, I'm going to go in order. This is C. And this one right here is going to be D. I'm going to have to label these two. I'm going to call this one, let's call it C, D. What would D be? What values is the same between these two? The X or the Y? The Y, yep. And I'm going to call this A. We don't know what A is. It's just another number. So that's what we have so far. These are my coordinates. We are going to restate our theorem using what we have. Let's call this point right here E, and this point right here F. I want you guys to restate my theorem right now, starting with if this, then this. State, restate. So if, what is my mid segment? EF. Yep, so if EF is the mid segment, of a trapezoid, which we're going to call it A, B, C, D, then what would be true using my midpoint theorem? I want you guys to discuss it with the partners next to you. Okay, I've already stated that. Has to be what? It would be this is yep, right there. You're close to the window, please. Yeah, I don't even know how to open them. Yep, okay, that's your first line. And keep going. Now, if things are parallel, they have to have the same what? Yep, thank you, Sonny. Same slope. Then, the slope of EF. I like the word congruent, but I'm just going to use equal because we're not talking about like sides. Has to be equal to the slope of AB and CD. Sonny, what is the slope formula?
y2 minus y1. It's minus y1 over x2 plus minus x1.
Yep, x1. So we're going to have to use that because we're going to have to prove this in a second. So then the slope of EF has to be equal to the slope of AB and CD. We also have its length is 1/2 the sum of the lengths of the bases. So we're also going to have to write that. And how do I find the length? Distance formula. Okay, what's the distance formula? Minus x1. Rogue, can you finish it? No, Rogue's not here. Ronaldo, can you finish it? No, you're fine. Yep. So we're going to have to use these two. I'm going to put this into equation form. EF has to be half of the length of my bases. What are my bases? Riley, can you tell me what the bases are? Same bases as before. Yeah, it's 1/2 my bases. So Vincent, do you want to help me out? What are my two bases? We're parallel to these bases. So what lines are we parallel to? EF is parallel to what two sides? Yep, okay, AB. And? Yep, CD. Okay, you guys have to prove those two things. Do you guys want to start off class on the board proving this for tomorrow?
Yes.
Yep, okay. Then you have